Hi everybody, I'm Steve. This talk is actually called Literate Programming in your menu presentation thing, but I changed the title to Software Composition because literate programming also means this thing that Don Knuth did, and I thought it was sort of confusing that it was similar, so I changed the title a little bit. But this talk is primarily about software as literature. So I think that it's really interesting to draw connections between programming and other fields. So sort of like that anthropologist from Ryan's talk, I'm actually getting more and more involved in the English literature and humanities community, and so I'm sort of drawing connections between programming and that sort of English writing. So this is a talk about how those two worlds connect and how that's useful to us as developers. Like, what can we get out of the things that the humanities departments are doing? So I'll leave a brief introduction on me. The main project I work on is called Hackety Hack. It was originally written by Y, the Lucky Stiff, and then he disappeared, so I decided to take it over. It teaches you how to program using Ruby, so that's neat. It's built on top of this other library called Shoes. So Shoes allows you to write cross-platform GUI applications for Mac, Windows, and Linux, and you just write one thing and you get them everywhere, so that's pretty neat. It's also fun as a Ruby project because it's actually written in C and not in Ruby, so I get to also code in things that are not Ruby sometimes. And then I run classes with Jeff Casimir at Jumpstart Labs, so I actually teach Ruby and Rails as a job. So a lot of educational related things, which is sort of how I got into this whole topic. So we're all here because we love Ruby, right? And I think that as far as this idea of programming as literature goes, that the Ruby community is a great place to have this kind of discussion because we care a lot about aesthetics. Like, the reason that we like to use Ruby is because it's a very nice language from a programmer's perspective. One of the things that Matt said he wanted to do when he wrote Ruby was to make programmers happy, and he wanted to create a language that programmers would find pleasing. So sometimes I think we listen to pretty a little too much, even when it does bad things. The reason that I program in Ruby as opposed to Java is because the way that the code looks, and so it's much more conducive to my way of thinking. There's a lot less punctuation and ridiculous things. I used to program in Java in university, and I hated every minute of it, and now I program on Ruby, and I love it. So when we talk about actually writing software, we have these guidelines that we try to follow, right? So people say things like write lots of comments, or use very descriptive variable names, make sure to indent your code properly, and use OO design. And all these things are great, but since they're sort of very general and not specific, it's really easy to say, yes, of course, I will definitely use object-oriented programming right, and then you have controllers that are thousands of lines of code, right? I was talking to Darcy, and he's saying earlier that he had a project that was 20,000 lines of code in a Rails controller. And that's a little extreme, but I have seen projects that are similar, that are like that. So we'll simultaneously say one thing and do the other, right? Like, I'm not a perfect programmer either. I write lots of really, really terrible code. And so while these things are sort of general, it's hard to actually apply them. So when I was thinking about this as a problem, this is how I started to draw this literature connection, because when we program, we're still writing text. So you're still using language the same way that you would be doing if you were writing an essay. And the humanities departments have been trying to work on how to communicate effectively, since the dawn of language, right? Like, that's a problem that they've been working on. And so while programming languages are new, languages are not new. So I wanted to see if there's a way that we could sort of take what they've learned with more human languages and applying them to software languages. So this is not an argument. The idea that software is language is not a hard thing to sell amongst you guys, because you all know this already. But when I talk to the English professors, they go, software, that's not a language. And it's people can't read it. I'm like, well, do you think that sign language is a language? And they're like, of course. I'm like, well, that's not even written down, right? So, and they say, okay. And then I talk about how Chomsky, so Chomsky has these ideas of Chomsky grammar, that is how descriptive a language can be, so like a regular language or a context-sensitive language or a context-free language. And so that's a linguistic concept that he used to talk about human languages, and that we use in compiler class to write about programming languages. So when I talk about how we use that same exact thing, those professors are like, okay, I can kind of see what you're saying. But so that's some of my examples of how these things are connected. This slide got a little squished because I wrote this presentation in Keynote and then exported to PowerPoint. But so when I mean by composition, this is the poor Yorick quote from Shakespeare. So when I think about what composition means to me, and the way that it's similar across writing software and writing an essay is that when you have a blank piece of paper or you have your blank Vim window open, you could write an infinite number of programs. Anything could come out, and your job as a programmer is to write the exact correct program for the program you're trying to solve, right? So every test we write, we're eliminating a whole series of programs that do the wrong thing, and we're trying to get it closer and closer to the one that's doing the right thing. So it's sort of like sculpture, where you have a block of stone, and then you're carving out the exact same sculpture you want. There's an infinite number of sculptures inside that block. So this is actually almost Shakespeare, but with a couple words changed around. So it's not quite Shakespeare, it's a slightly different essay. And so that's one of the reasons why I love test-driven development, is because it reminds me of sculpture. So that's another weird comparison that I think about sometimes. So the meat of this talk, that's sort of the introduction, is divided into 3 big parts. And because I've been reading far too many philosophy books lately, the titles have some complicated words in them, but they're not that bad. So the first part is the multitude of audiences, which is talking about who you're writing for. The second half is the multiplicity of forms, which basically means the different ways that we write things. And yeah, because I've been writing papers for conferences, I've been using large words. And then the last thing is, if we think about software programming as literacy, then there's some problems that have come along when you think about what illiteracy means. So that's the third part. So those are the 3 things I want to talk about. So, okay, so a bunch of audiences. This is really useful when you're thinking about what documentation you need to write or what code you need to write. So there's a couple things that go into this. So when you're writing a program, the very first thing that you need to write is a program that you can understand later, right? So you need to write code for yourself. So Don Knuth had this quote: "Science is the things that we understand well enough to explain to a computer, and art is everything else that we do." So yeah, with the amount of drinking that goes on at Ruby conferences and Ruby stuff, I've definitely written some code that the next day I scratched my head and I said, what did I even mean, yesterday? So you have to be able to write code that is clear enough to understand later, even for yourself. This is one of the reasons why I switched to Ruby from doing Perl, right? Because I could never remember what my Perl code did, a couple days later. So that's important. So this is like a good thing to think about when you're trying to write, variable names. You want them to be descriptive so you can remember later. If you want to add a couple comments, that's for you later. Somebody who knows the code really, really well. So the second one is other programmers. You have to write your code and your documentation in a way that other programmers can understand. So Brian Kernighan said, debugging is twice as hard as actually writing software itself. So if you write the most clever code possible, then you're not smart enough to debug it by definition, since it's harder. So you want to try to keep your code simple, and this is the reason that we write things like API documentation, is that so other programmers are able to use our code properly. And that's why tools like Yard come in really handy, because API documentation is really good. But it's also not necessarily enough to just write API documentation, right? So then there's the other audiences are for people that aren't necessarily programmers that need to use the software you write, or that people that are like coworkers that are less familiar, so maybe somebody on another team. So always code as if the guy who ends up maintaining your code is a violent psychopath who knows where you live, is another one of those rules I try to think about. It's sort of amusing. But this is why Rails guides, for example, are awesome. So just having API documentation isn't enough. Guide-style documentation can really, really help people understand how multiple parts fit together. When we write tests, ideally you're writing unit tests and you're writing acceptance tests because they serve two different purposes and they work together. You can't just have acceptance tests or just have unit tests, or you can, but it's not as effective as if you write both, right? So the sum is greater than the whole is greater than the sum of its parts. So that's one of the reasons why guide-style documentation is really effective. And it's really important. I'm glad to see we've started getting more into this as Rubyists. Lots of people use Yard to write API documentation, or at least they write some random documentation and then run it through Yard and put whatever comes out online, right? But so this has sort of gotten a little more attention lately. And Doco is a really interesting tool from Jeremy Ashkenas, who's the guy who wrote CoffeeScript. And he used to be a Rubyist a couple years ago. He sort of moved into JavaScript now, but it gives you really beautiful API and sort of guide documentation. So the last one is something that we don't really necessarily think about too, but not only do you have to write code that you can understand it, you have to write code that your coworkers can understand it, but you also have to write code that your end users can end up understanding. So they don't read our code directly, but they do read the thing that our code produces, right? So my favorite Henry Ford quote, and I actually heard about this through Steve Jobs, this makes a lot of sense if you think from an Apple perspective, but if I asked my customers what they would have wanted, they would have said a faster horse. Right? So you have to write things that your customers actually want to use, not necessarily what they tell you. I have a project right now that I'm doing for my mentor, and so my customers are not actually her, it's her customers, and so there's some problems where she tells me what they want and then I build it, but it turns out that she told me the wrong thing, and so I have to rebuild it over and over again, right? So it's really important to talk to the people who actually use your software and make sure that you're not writing a bunch of features for them that they're not going to end up using. So during that project, I did manage to make one good decision, and I pretended to implement a feature that they said they wanted because I knew they didn't really want it, and it turns out that they never actually used it and then asked me to remove it anyway, so I saved myself a couple hours because I faked it really terribly. So it's important to keep your end users in mind as well, as far as like the audience of the thing that you're trying to write. So that's all about like the different people that need to read the code that you produce, and so the comparison I see between literature, I guess. So a bunch of different forms. The other thing that's interesting and what makes programming a much harder thing than writing an essay, and still sort of language-based, is that we have to, when you're writing an essay, you're composing it in your, maybe native language or maybe another language, but you only have one language. But in software, we're actually composing in multiple languages at once, and so that's really hard. And so that's the second part. So this quote is a little hard to read because this font is a little thin, but it's from the poem Jabberwocky. I think it's Rudyard Kipling. But it's essentially nonsensical, even to like, he mostly wrote English prose, but even to an English person, it's nonsensical, but it sounds really interesting as a poem. And whenever I took my my secondary like logic class, we used examples. It helps a little bit. You try to prove that like, so a tove is a random word in there, and so we're trying to infer like, do these sentences make sense, even though they're like nonsensical from a understanding perspective, from like a logically constructed way, are they sensical? But so we need to actually compose in source code, and that's the first thing that you need to worry about as far as like the medium that you're, if you carve a statue out of stone, the equivalent of stone in programming is actual code. And while it seems obvious, there's a couple interesting examples of people doing neat things with programming languages. So this is the shortest possible quine in Ruby. A quine is a program that prints its own source code. So if you run this program, it will spit out this text. And it's abusing the here doc syntax and some other weird things. But this is the shortest possible one that I could find. And these things get really, really crazy really quickly. But so this is sort of like artistic source code, right? So it's more like a sculpture in source. But what's really, okay, so maybe this is a very simplistic one. There's this one right here, which I'm going to show you. It's kind of crazy. Oh, this didn't show up well at all. So this is a globe. Some crazy Japanese guy wrote this Quine, and it actually spits out 7 or 8 iterations. So I'm going to click through, and you can sort of almost see the globe rotates. So this one spits out the next rotation, which spits out the next rotation, and it actually ends up back where it started. So it's a program that spits out a picture of a globe that is spinning through all those ones. So yeah, so there's that. This is part of a Perl poem, so called Black Pearl, that was posted to Usenet in the 90s with forged email headers that said that Larry Wall wrote it, even though he didn't. This is the guy who authored Perl. So this is, beforehand, closed door, each window and exit, wait until time. And that's valid Perl code somehow. It doesn't actually do anything. It spits out some random numbers, if I remember correctly. And this is only the first stanza. But if you Google Black Pearl, it's like a full page and a half of poetry that is valid Perl syntax. And since Perl and Ruby are very similar and have a very common tradition, the colors didn't show up here really well, but this is actually a poem written in Ruby, so it's the first one that I know of. So, eyes scan the darkness, catch in the winds, a something breath, or a piece of moon. So this is written by Y the Lucky Stiff, but again, it's valid Ruby syntax. You could run it through your Ruby interpreter, it would work. Also, possibly a poem, depending on how you look at things. So that's some interesting ways that you can compose something that's sort of artistic, even with source code as a medium. So one of the other interesting things about the mediums of programming is binary. So this is a quote from the Buddha. Unity can only be manifested by the binary. Unity itself and the idea of unity are already two. So normally we don't have to worry as Rubyists about the binary code that is spit out by our compilers. But I have friends who do operating systems research, and they care a lot about the actual binary code and assembly code that their compilers produce. So sometimes this does happen to us in the Ruby world, though. So this was Joe D'Amato wrote a blog post on his blog called The Broken Promises of MRI, I want to say 6 months ago. And he wrote some Ruby code, and it turns out that the C code that was generated by MRI from that Ruby code had a bug in it at the assembly level, and that caused his Ruby program to have a bug in it. And so it wasn't even the Ruby's fault, it was the compiler's fault due to some GCC optimization or something crazy. So every once in a while as a Rubyist, we do actually care about the binary code that is spit out. And so that whole idea of source code or binary code, they're sort of the same but not quite, is something that I think is interesting, that you occasionally do need to worry about. This is why I like that Shoes is written in C and why I like to still program in C. Most of the time, I love Ruby, and the vast majority of code that I write is in Ruby, but it's always still good to remember how the lower level things work so that you can debug problems when this happens, right? So I know lots of people who Ruby is their first or second programming language, and if this ever bit them, they wouldn't be able to solve it. And I probably wouldn't either, but I would at least be able to diagnose that it was a problem with the compiler and not, with Ruby. So sometimes we care a lot about binary code. The other one is, or another one rather, is code versus data. So the progression of the Lisp programmer, the newbie realizes the difference between code and data is trivial. The expert realizes that all code is data, and the true master realizes that all data is code. So when you're designing your application, you have to choose how much information is going to be stored in things like config files and how many things are going to be Ruby code, right? So we have database.yaml, which in a Rails project, which has all your database connection information as a YAML file, which is data, but then the router is written in Ruby code as a DSL. So why don't we have the database configuration as a DSL? Or why isn't the router a YAML file instead of being Ruby code? It could be either way. It's not necessarily right or wrong, the decisions that they've made so far. But that is an explicit choice that you have to make, right? So I helped. One of the really interesting things about JRuby is that, at least in America, a lot of the big giant companies that have a lot of code in Java are looking to get into Ruby, and they're doing it by building JRuby on Rails applications that talk to their existing Java code. So I've done a couple consulting jobs for these kinds of companies that are sort of transitioning to doing Ruby that way, and so they have totally different norms, like we were talking about the 4-space versus 2-space indentation, for example. The two of the companies I worked for wanted to store all of their configuration information in the database, right? So config files were totally out. They wanted it all in the database, and that caused all sorts of crazy problems. But making those kind of decisions about like what goes in config files, what goes in DSLs, and how do you move between them is something that is a hard and interesting sort of choice that we have to make as programmers about how we put our programs together. So Polyglot is another thing. Polyglot is multiple languages. So this is a conference where we're speaking in multiple languages, right? Or at least you all are. I'm a dumb, ignorant American, and I only really know English. I did take a year of Japanese, though, but there's no opportunity to learn anything but English because nobody else speaks it in America. So I really would like to learn more human languages. That's sort of neither here nor there. But this is a quote from the Tao of Programming, which is a really funny. It's sort of written in the style of Eastern philosophy about programming. So the Tao gave birth to machine language. Machine language gave birth to the assembler. The assembler gave birth to the compiler. Now there are 10,000 languages. Each language has its purpose, however humble. Each language expresses the yin and yang of software. Each language has its place within the Tao, but don't program in COBOL if you can help it. This is something where, as Rails developers specifically, we program in multiple languages all the time, right? So you have Ruby for your main application code, and then you have JavaScript, or maybe CoffeeScript on top of that, and then you have CSS or maybe Sass. And so, we very explicitly program in multiple languages on the same project all the time. But, there's going to be a presentation later about Erlang and Ruby, right? So if you have a job queue and it's written in something else totally different, then, you need to put all these things together. And so, which components of your application go in what languages and why? How do you combine them? With Ruby, we have like FFI to interface with C libraries, or you could write a traditional C extension. And why would you choose one or the other? And how do you cross that bridge? So that's sort of an interesting thought about how we put programs together, too. So then there's over time. So it's sort of weird to think about like how do you put software together? How do you compose software over time? This is a quote from a essay called "The Work of Art in the Age of Mechanical Reproduction" by Walter Benjamin. It's an essay about how photography changed painting. So whenever cameras became more ubiquitous and people had cameras, people were thinking like, oh, is painting going to go away now that we can take perfect pictures? Why would anyone paint a portrait of someone? Or why would we paint a nature scene when you could actually go there and take a picture of it, right? So, so he was talking about that, and so that's the way I think about a lot of software stuff is sort of similar, right? Like we have all these jobs that are now being automated via software. And so I won't read this one because I'm going on a little long, but basically, when you're thinking about like Git commits, you're trying to remember what you did in the past. So like the art of writing a good Git commit is sort of like building software over time, and how do you branch things and how do they go together? And so we sort of have a time element how we're programming too, right? Like is your program just the current instance of your program, or is it all of the versions of your program over time? So and that's kind of interesting, and there's some interesting stories. So as somebody who did take over someone else's code who is now gone, there's definitely an instance of like, you can see where I took the code that Y created, and over time little bits and pieces of it become mine, and there's sort of interesting stories that can be dug up out of there. So there's that. Again, sort of Git is integrating multiple copies. So if someone forks your project and writes some different things and contributes back, how do you put those contributions together, right? Like if you merge patches in different orders, then you can have merge conflicts, but if you change it in a different way, you don't. So putting multiple copies of things together is something that we have to worry about. And also when you're building a web app and you have tons of different app servers that go behind one proxy server and all that kind of thing, we have to manage multiple copies of our code as well and put them together, which is composing. And then, so multiple representations of the same code. So if only you and dead people understand hexadecimal, how many people understand hexadecimal? And the answer is 57,006, and that's because dead is 57,005 in binary, or in base 10 as opposed to base 16. So it's sort of a play on the fact that letters can also be numbers. I actually had this argument with I have a new roommate, and she asked what the password to the Wi-Fi is at my house, and we said cafe babe. And she's like, oh, that's why did you pick that? I'm not really sure what you mean. And they're like, well, because it's a number, and you need hexadecimal numbers for the router. And she was like, wait, it's not really a number. And I was like, yeah, it is. It's just, so we got in this argument about, is it still a number if it has letters in it? So this happens, with the whole CoffeeScript JavaScript thing and the whole Sass CSS thing, right? It's like two different forms of the same thing. And, how do you pick and convert stuff over? Now that CoffeeScript and Sass are becoming normal, there's a lot of Rails applications that are legacy that have, their old JavaScript file that has all their old JS, and they're writing new stuff in CoffeeScript. And so you have them alongside each other. And so, that kind of thing is something that's an interesting, hard deal. Backporting, software is like sex. If you make one mistake, you'll be supporting it for the next 18 years. If a bug gets fixed in... If you fix a bug in a new version of their software, there's still tons and tons of people that are running old versions of your software, right? So Rails 3 has been here for over a year. Rails 3.1 is new and shiny. But Rails 2.3x still has almost as much. There's like 50% of Rails applications are still running Rails 2.3, right? So if you find a bug in the newer versions of Rails, you have to convert them back to the older ones too. And so managing how do you apply patches from new versions, and what happens when there's a bug fixed in the JavaScript renderer that now uses the asset pipeline but didn't use it before, so you have to almost rewrite a patch, or 2/3 of a patch to make it work with your old code, even if the bug is still there. There's all that kind of thing. So, so that's a complexity that we have to manage as software developers that when you're writing essays you don't have to manage. And then levels of abstraction. So this is the quote from the Turtles All the Way Down story, if you know what I'm talking about. It's about an old woman who thinks the whole worlds are on the back of turtles and that it's just turtles forever. So we have to pick how high or low level of a language to use, right? So I could write my entire web application in Rack. So I could also write it all in Rails. This is the first talk that we saw today, is about how do you pick the appropriate level of abstraction to write your application at. Do you write it in a super low level way? Do you write it in a super high level way? Is Rack too high level, right? Should I be writing a CGI extension in C? And the answer is always no. But sometimes, theoretically, maybe it could not be no. So, there's an explicit decision that we have to make as programmers. I just got done porting two Sinatra applications to Rails because they started to grow too large and Sinatra was becoming a problem. So, those kinds of things happen. And that's a good reason to actually use Active Record in your Sinatra projects, is you can move them to Rails easily later. So that's a choice that we have to make as programmers. And then, so that's all the stuff about composing in English and all those things that I see comparisons between literature. So if we accept this premise that software is literature and that programming is composition and writing, then there's this other thing that comes along too, which is, well, what happens to illiterate people, right? So if software is literature and we are the literate, what happens to all the people that aren't? And so I've lately been thinking about software as a crisis of literacy. And so this is, again, useful with a multiple languages conference, but an aside to my aside about software as literature is one of the weird things about the terminology differences between humanities departments and software is that our terminology is entirely different. So when I say crisis, I'm actually meaning a point of great tension in a story that determines how the action will come out. So we're at this weird tipping point. So for example, when I was doing this work for my advisor, the people said, oh, this feature on the website doesn't work. And I said, oh yeah, that's terribly broken. I'll take care of it. Don't worry about it. And they were like, no, your work is really great and it's fine and we're mostly happy with it. There's just a little bit of problem. And I was like, yeah, I know, it's broken. And they're like, no, we're not trying to insult you. And I realized that if you tell an English professor that their essay is horribly broken, they get really, really offended, right? Because it's a really great insult. But as programmers, we're like, oh yeah, that doesn't work. Sure, yeah, right. So that terminology difference is a really big problem when bridging these two gaps. And lots of arguments on the internet are really about terminology. So when I think about us as programmers, if we're the literate ones, it's sort of like the problem is that we're scribes. So back whenever books were first being written, right, you had a small amount of literate population. So writing was a really great asset, right? Scribes lived a relatively good life. even if they were from lower classes because they had the skill. And so it's the same deal with programmers where we are the gateway to the technology that runs the world, right? Like all of the internet is built on stuff that we in this room know about, and normal people don't know anything about it. So, you know, this has been, you know, sort of like for me coming to this country and not knowing anything about the language, you know, now I'm the illiterate one. And so that's how normal people feel when they're using their iPhones, right? Like we sort of know how that stuff works and they don't. And what happens to people that don't even have computers, right? So even if you have a computer, you're one step away from understanding code. But if you don't even have computers, right, then you're even farther. So as we build a world that's more and more based on technology, what happens to the people in Africa that that have problems getting electricity to their villages, right? Or anywhere else where there's problems with that kind of thing. So the One Laptop Per Child project is a great way to like get over that first hump of like, to be literate, not only do you have to have the knowledge, but you also have to have the physical goods, which is a problem. So there's that too. So anyway, that's all I have for you today, some random thoughts about things. So thanks a lot, and I guess, yeah, questions?
Hi Steve, I'm Victor from Minsk. So you said that you know a company which stores all the configuration in the database. So in this case, where connection settings to the database are stored?
So, yeah, so you laugh, but I'm just like, oh God. So in their database.yaml, they have a configuration to one master node. And then in that one, there's a table that holds the connection data to all of the other nodes. And so they actually were grabbing that data out from that one connection and then configuring it all later and trying to, and it's just like, oh, yeah, it's really bad. But it was all the other stuff too about like, they had like translation information in the database and like all this other stuff. So yeah, so there was very, very minimal config files. And then everything else was all in tables. So,
is this configuration stored somewhere in source control? Because from my experience, this kind of settings should be in source control.
Yeah, best practice is absolutely to keep those things in source control. This is actually a large problem because of migrations, right? So they needed to be able to set up some default information, but they couldn't wipe away changes that had been made to the default. And so like it caused endless problems. So yeah, the right thing to do is definitely, you know, keep it in, you know, so one of the good reasons about DSLs or configuration files is that they are in your source control, and that's absolutely the right way to do it. But people, you know, clients think they know better. So what are you going to do?
I have a question.
Yeah.
How much time did it take you to migrate from Sinatra to Rails, your application?
So, yeah, so I did two projects. One of them was largely me and two other people. The other one had 5 or 6 of us. Both of them were sort of on the order of 6,000 to 10,000 lines of code, and it took us about a month each time, roughly, I guess. So it wasn't too bad because we had sort of followed Rails-style conventions when writing our Sinatra app, so a lot of it was similar, and we had a great test suite, so I was able to still run my tests. And that was actually how we did it, was we made our tests run, and then they all failed, and then just slowly started fixing tests, and so that was sort of picked up, you know, like redirect in Sinatra as redirect to in Rails, or maybe it's the other way around, I always forget. But you know, those kinds of errors were caught by our tests, and so I wouldn't have wanted to do it without a great test suite, but that was about how long, it's I guess a month-ish.
Mm-hmm. And maybe you can give some recommendations of criteria how to best select the Ruby framework, Sinatra Rails, and this is also a question to Alex Snyden, who was the first about that.
Yeah, so I guess my current thoughts are, if you have if you have a website that is less than, let's say, like 10 different pages, then it makes sense to do Sinatra. But once you start getting over that point, whenever one file gets too big, or you start splitting it up so that you're acquiring a bunch of other files, that's sort of the point where Sinatra kind of starts to break down and Rails becomes way more useful. I've also used Sinatra to wrap sites that are like, if your site is 85% static HTML pages and a little bit of dynamic stuff, then Sinatra is also really, really great for that. So I'd really say it comes down to, yeah, the size of the website, really. That's probably roughly about what it is. I would never code anything in Rack directly unless it was incredibly tiny. So I have one website I'm about to deploy that's Rack only, and its entire purpose is to serve example Ruby code stuff. And so it's like a 30-line class that's just Rack. So if it's anything over that, then yeah, I would never use Rack directly.
I have a question. I noticed at the very beginning of your speech you were mentioning how the recommendations we have for best practices were overly general, and in actual practice we don't actually use them. I've noticed this problem myself, and I was wondering if you had any recommendations for learning more specific best practices that we'd actually use.
So I don't have the answer to that question yet, but what I'm doing to try to figure out the answer is basically reading a lot of books. So I just had like 3 Amazon orders came in, and I have a stack of books that are like this, literally this tall, one of which is Object-Oriented Software Construction, which is a really crazy big book that Jim Weirich, who's the guy who wrote Rake, recommended to me. And so I think that really it comes down to sort of judgment and taste. So like, graphic designers, for example, like they sort of have guidelines, but they're also very general, and they're, you can break them sometimes if you have good taste and you know how to break them. So I really think that to do it well, you have to write enough software that you sort of can figure it out on your own. I'm not really sure I'm trying to decide if we can even have useful like best practices that are around things like coding style. I mean, some of them are, but like, again, you get into a different programming culture and they have totally different rules. So like, is it entirely arbitrary? I'm not sure. I'm still working on it. But yeah, I guess that's the best thing I have as close to an answer as possible.
Imagine that you have a piece of code that looks like Perl. Little hex and spaghetti and so on. Could you define the appropriate time frame to make this code look like code poetry?
So I guess the time frame really depends on the length. But if you're in a situation where you inherited code that looks really terrible, there's a book called Working Effectively with Legacy Code by Michael Feathers, and it is really, really, really good. The whole book is basically like a cookbook for, I have a class that is 10,000 lines, how do I test it and figure out what it does? I have this function that's really complicated, how do I figure it out and what does it do? And so the best way, as far as timeline goes, yeah, it's entirely dependent on the length and how good you can tease it apart, but the biggest thing is to get stuff under test so that you're not breaking it as you're changing it. And so yeah, I would check out that book because it's really, really good. It actually made me, it didn't teach me anything, but it made me feel really good about my ability to fix code that's terribly broken like that, because I have inherited a lot of code that is very, very complicated. And so I was really depressed about like, oh, I'm never gonna be able to fix this. And I read that book and I was like, I already knew all this. Yeah, I definitely can fix it. And it made me like very happy about it. So, but yeah, that's what I would say, I guess.
Hi, Steve. Nice speech. My question is, you say about different meaning of problem between programmer and customer. How you deal with that? No, for example, your customer say, make a big screen. You make big screen, but it's not what he want to do.
Mm-hmm. I guess the biggest thing that you can do is try to try to think about why they want the things that they want, right? So there's that rule of thumb about the 5 whys, where if you ask why 5 times, you get to like the root cause. And if you do that to your customers, they'll generally get agitated with you. But if you try to think about like what their root cause is and ask a little bit of questions, you know, you can get it sort of what they want. The other thing to do is simply to like charge people for things that you know are dumb. So this is what people are doing with Internet Explorer 6, right? Is that like, yes, I would love to support Internet Explorer 6 with my website. That'll be an extra $5,000 on top of the regular quote, because it will cost me, you know, if you say like, you know, doing this feature seems like a bad idea. I would love to program it for you, but that's going to be an extra hourly estimate on top of the rest of the project. Or, you know, maybe you break out, my roommates have a consultancy, and what they do is if they have any features they think are problematic or they think that aren't going to be a good idea, they'll give a quote with those features broken out. So they'll say like, oh yeah, so we think the most of your project is pretty easy and we'll do it for, you know, $20,000, but then these 2 features that you wanted are really hard and they're going to take extra time. And so even if they're not necessarily technically hard, if they think it's something a customer won't want, they'll just tell them that it's hard, which is a little white lie. But that way the customer still gets to make an informed decision. If they want to pay you to do something stupid, then it's their money, not yours, right? So their latest project is a social network for deer hunters. That some dude is paying them $50,000 to write a website to do that. And they're like, are you sure you want to do this? And he's like, here's $50,000, and they're like, okay, that's out of my hands, right? So you can't stop them from building things that are bad, but at least if they pay you for it, you feel better about it in the morning, right?
Thanks.
I have a question on your presentation. You were comparing literature to coding. When I think of literature, the writer always chooses the word. He can spend many minutes trying to figure out what's the best word to fit here. And in code, I feel the same. Sometimes 10 minutes, hours to say, I'm trying to define what's the entity, what's the best word for this entity that I want to place. And sometimes happens that I'm looking in code and I see that my terms that I choose for this model, for example, is not defining this model. For example, I had a task in task tracker. No, it's not task, it's bug. No, it's issue. And does it bring the code to refactoring if you think that this term is not appropriate here in this part?
Yeah, I mean, naming is really important. So actually that error about like thread does not have find is like my second or third error that I got with Rails, because I did the exact same thing. I was like, oh, I'll build a forum, and then that happens. So naming stuff is hard, and it's also difficult when you're in something like that that's a non-technical decision. It is really hard to like to figure out what's right. And it's hard to convince other people that they're wrong if you feel that they are. And so I've had this with working on teams too, right? Where it's the same thing, like, oh, do you name a function this or do you name it something that? And you go through code review, and then the person reviewing your code says, like, I think that name is terrible. So I think it's the same sort of thing about the best practices. You sort of have to develop a style, and you have to read a lot of other people's code and, you know, talk about it a lot. And I don't know if there's any like hard or fast guidelines to like getting it right, other than making lots of mistakes and not being afraid to make lots of mistakes over and over and over again, right? So I actually have, I started programming when I was 7, and I did it in BASIC, and then by the time I got into 7th grade, I was writing in C. And so I actually have some of the source code that I wrote when I was like 10 years old in C, and it is terrible. Someone asked me to put it on GitHub once, and I don't want to because it's so bad, right? But you end up learning as you do it, and you sort of like find it eventually. And that's sort of a crappy non-answer, but it's the best thing that I know. I don't think there's any like real good rules other than just doing it a lot and getting confused by your code later and trying to do better every time you write new code. So.
Hello. Continuing your analogy between literacy and software literacy. So do you think that just like now the majority of people know at least a single natural language, do you think that in future at least the majority of people will learn at least a single programming language?
Yeah. So yeah, this is actually a question I get asked a relatively large amount, and I think that it is true to a certain degree, right? So people do know a single like natural language, or hopefully more, but they're not writing essays every day. and they do like speak a language, but they don't necessarily think about grammar and syntax. They just kind of pick it up. And so I think that eventually a large number of people will be familiar with the way that programming works, in the sense that they know that you type text into an editor, you hit compile, and it makes a program, and maybe they have some sort of vague understanding at that level, or they know basic logic. But I don't think that it's something where some people try to think that eventually everyone will be programming at least something, for example, and I think it's going to be much more basic than that. Like, I don't think that everyone will be programmers, but they might know more about programming than they do right now, right? Like, my parents my grandma actually asks for to see videos of all of my talks, and she doesn't know anything that I'm saying. She's like, I just really like to see you talk, even if I don't understand the words that are coming out of your mouth. So I think that people will have a very, very basic knowledge, but not do it all the time, right? And that's part of the thing that open source people talk about, well, if the code is open, anyone can change it because anyone can fix bugs because they can read it, right? And I've never fixed a bug in Firefox, and I wouldn't know the first thing about how to do it, but at least I understand enough about C++ programming that I know that a bug could happen for a logical reason or something. I'm thinking that support calls for turn my modem off and turn it back on again, people will be a little farther than that in their knowledge, but I don't think that everyone will be programming stuff often, just that they'll know more about it than they do right now. Because people just don't want to, right? So my girlfriend knows C, but she doesn't program things ever, and she hates doing it every time she has to do that, and maybe because it's in C, but she's literate but doesn't use it. So I think that's people will be more like that, I guess.
Thank you, Steve.
Thanks a lot.
For all you guys who want to ask Steve any further questions, just find him when it's lunch.
Yeah, come find me. And yeah, when I'm drinking, the answers get even funnier, and I tend to rant even more. So just come find me later, and yeah, I'd love to talk to anybody.
Thank you, Steve.